week on the PBS channel. Sorry everyone. Welcome to Did You Know? With Carter and Jeffrey. Do you like our new setup? Anyway, today we are talking about the elements. I just was saying that.
As you can see on your screen right now, you're looking at the periodic table, right, Carter?
You sure are.
Tell them a little bit about the periodic table, if you would, while they can see it on their screen right now.
Well, the periodic table is a table with a chart of elements. Mm-hmm. This is one of our questions today. What are the elements? The elements are a chemical substance with a single type consisting of a single type of atom, which can have a different number of electrons and protons, depending on its atomic number.
Yes. So an element is a pure thing. It's not a mixture of things. Like, would water be an element?
No, it's something called a molecule.
So water has what elements in it?
Let's see. Hydrogen and oxygen?
Yes.
That's why it's called H2O.
That's right. 2 hydrogen atoms and 1 oxygen atom together. But an element would just be hydrogen with nothing else combined with it.
Hydrogen or just oxygen.
Or just oxygen. So where do elements come from?
Elements come from stars.
Wait a minute. So are there like spaceships where the elements are made and then they're shipped here by spacecraft, like on a freighter or something?
Stars,
okay. But how does a star make an element? Is there like a bakery or
It has something called fusion. It has something called fusion in it.
Okay, tell me more. What is fusion?
Fusion is when two atoms, in this case, in the star's case, hydrogen, smash together at really high speeds in a really hot environment, very hot, to create helium.
So these two atoms of hydrogen, which is one element, smash together and all of a sudden they're a different element?
Yeah, they smash together, but yes, and they repel each other.
So when they smash together and they make helium, then there's a whole bunch of energy released, right?
There sure is.
So
that makes light and heat.
So what you're saying is that the sun, even our sun, up in the sky, is up there smashing away hydrogen and turning it into helium right now.
It sure is.
And that's what makes the sun like bright and hot and that amazing ball of fire?
Here's a fact.
Yeah, tell me.
If it's a shorter distance from the sun's core to its photosphere, which is the outside.
Okay.
It's a shorter distance than the 8-minute journey from the sun to Earth. It actually takes thousands of years from it to get to a shorter distance.
So in the very center of the sun, where all this fusion is taking place, the particles and the heat and the energy that's created takes thousands of years to get to the outside, just to the outside of the sun.
Yes.
And then it only takes 8 minutes to get from there to the Earth.
Which is a longer distance.
Which is a much longer distance. Wow. So I heard that the distance from the sun to the Earth is 93 million miles?
93 million, roughly 93 million.
So if it can do that in 8 minutes, how fast is that light going?
That light is going, I think, the speed of light.
The speed of light!
Which is the speed limit of the universe. Nothing can go faster. If something did go faster, time would stop. But not in all places, just for that one thing going the speed of light and over the speed of light.
So you're saying that, if I may quote Einstein, I think Einstein wrote this, time approaches zero as mass approaches the speed of light?
Yes, Einstein actually made that saying up.
Wow.
He actually made an equation about it, and it's on my sign over there, E equals mc squared.
Oh, that's so cool. All right, I have another question though. So that's fusion. That's nuclear fusion, right?
Nuclear fusion.
So
But
what's nuclear
fission.
fission? What's that?
Fission is the opposite of fusion because when one neutron comes into one atom, it splits apart other atoms, but that's only if it's a huge atom. And it's really unstable. And when it bangs together, sometimes it flies out, sometimes it creates a new element.
Well, yeah, so you can take an element and bombard it with all kinds of neutrons and sometimes make new elements that way, right?
Yeah, but you can only make them for a few seconds because then it moves back to the second element you created it from, then back to the other one, then back to the other one. That's called radioactivity. Until it finds an element that is stable, it's still going to do that.
So it keeps spitting off particles until it reaches a place that's stable.
Yes, and when it's stable, basically you can handle it.
So when inside these stars where the elements are kind of being cooked up, in our sun,
I'm
hydrogen...
making an element cake. And it's really hot in here. I'm going to have to get some more fans in here.
It's awesome
I'm
that not only do you get facts,
an
but you get
element
music
cake.
at the same time. It's, oh, wait a minute. There's something we forgot to talk about.
Okay.
Can I just say, I love your bow tie.
Thank you so much. This bow tie was from my friend Troy Miller. He has this great website called Bowtie Me. You can see all of these different kinds of bow ties. They're amazing.
Right, and I want to make it clear that this bow tie was handmade by Troy Miller, and this isn't like an ad. It's not a commercial we're doing for him. He just did it, and we think he's awesome for doing it and making this wonderful tie for Carter.
We sure do.
Because he loves bow ties, and he saw Carter wearing a bow tie in one of the episodes and said, hey, you got to wear one of mine. So
I think
there
that
you
was
go.
the plane episode.
I think so, yeah. So, all right, back to fission. So, in a nuclear reactor here on Earth, do they use fusion or fission?
They use fission, but it's hard to it's a little hard. So they're trying to use fusion instead. Fusion can, for one that lasts more than there is one in China that lasts about 30 seconds. That's a long time for a reactor like that.
So they made a fusion reaction for 30 seconds, which is
Yes,
great, but you're not going to power a city with that.
Yeah, you can. You can power a city with it. You sure can.
But you need it to last for more than 30 seconds.
You do?
Yeah, because you got to have it going and going and going and going and going and going.
Well, it can supply power, but not. It can supply a lot of power, but it can't really supply a lot of power for a long time.
Right.
China, if that reactor becomes, if that Chinese reactor becomes a operational reactor, then it will have to start giving energy to places like outside of China.
Well,
like
I mean,
places beside it, like Russia and places like that.
I'm not sure the Chinese are going to give energy to China
but
away.
Yeah.
But that's a good point that eventually they'd like to create power using fusion because fusion is a lot cleaner than fission, right?
Fission, you have to store all of that waste.
Yes, and it's radioactive, and it's radioactive for like 100,000 years, right?
Yeah, it's usually just 2,000 or 3,000, but that's kind of as long as humans have been in evolution. They started like 2,000 years ago, and they went up to 2014. So
I think evolution started more like a couple 100,000 years ago.
Okay.
But you're human evolution, yeah. I think the first human was
human revolution or evolution.
But wait, we're not talking about evolution right now. We're talking about the elements.
Or revolutions.
Thank you. Nicely done, my friend. So, all right. So we've talked about fission, which is the splitting of atoms. And we've talked about fusion, which is the crashing together of atoms. But this is about elements, right?
Yes.
So what are some specific elements? Let's talk about some specific elements, shall we?
Dad. Oh, there it is.
Yeah. The first one we're going to talk about is carbon.
Carbon.
Now, I am going to bring out a pencil.
A pencil, just an ordinary
Do you know
pencil.
why I'm bringing out a pencil?
I sure do.
Is there carbon in here?
It sure is. That very tip is made of graphite.
And graphite is carbon?
It sure is. It's a form of carbon. But diamond is as well. Diamond is the more see-through kind, and graphite, I can hardly see through it.
But they're both carbon, right? They're both the same element. So how can graphite and diamonds both be carbon and yet be so different?
Well, they're so, well,
Can I jump in?
yes, you can.
So if you take carbon atoms and you just kind of smush them together, you get graphite. But if you compact them under high pressure and heat, kind of like with fusion you were talking about, but on
Yeah.
a lesser scale,
Yeah, maybe.
then they form a crystalline structure, and
Yeah.
that is a diamond.
Well, you might want to do that with a trash compactor at the beach in the summertime while they're having a heat wave.
It takes a little more pressure and heat than that.
A
You know what?
trash compactor, that isn't enough.
Wouldn't that be great if I could just put pencils in a trash compactor and diamonds would come out? I'd be doing that all day long.
Diamonds.
All right, now you can't show them that you're an evil genius quite yet.
I'm not an evil genius, and I'm not evil, and I'm not really a genius.
I'm going to read the first carbon fact because
Maybe
it's
a
got
little
lots
bit
of
of a
words
genius.
that are crazy. Can I handle that one?
Yes.
All right. There are 3 naturally occurring isotopes, with 12C and 13C being stable.
I say like C12 and C13.
Decaying with a half-life of about 5,730 years. What's a half-life?
Wait.
Blah, blah, blah.
You've skipped a
Blah,
part.
blah, 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 blah.
You skipped a part.
What's a half-life, though? I'll go back if you tell me what a half-life
Okay,
is.
a half-life is how long a radioactive particle stays around in a radioactive area.
In a radioactive state, that's right.
Yes.
And so in 5,730 years, half of it will be gone.
Yes. Wait, actually,
That's why they call it a half-life.
oh,
Yes.
you skipped this. This is how you didn't treat it.
All right.
There are
please.
3 naturally occurring isotopes, with C12 and C13 being stable, while with C12 and C13 being stable, while C14 is radioactive, decaying with a half-life of about 5,730 years.
Mm-hmm.
There are 3 naturally occurring Whoops.
We could say it again, but they've already heard it.
I accidentally copied and pasted twice. Oh, I forgot.
Oh! All right, so carbon is the 15th most abundant.
This is your Homer Simpson.
Carbon is the 15th most abundant element in the Earth's crust and the 4th most abundant element in the universe by mass, after hydrogen, helium,
And oxygen.
So there's a
And
lot of carbon
oxygen.
out there.
A lot of carbon out there.
Carbon out there. There's a lot of carbon in you too, my friend. There are several allotropes of carbon, which the best known are graphite, diamond, and amorphous carbon.
Graphite, diamond, and amorphous carbon.
Amorphous carbon. I would like a bowl of amorphous carbon, please.
And also on our last episode, the episode before the last, it was the plane episode. I forgot to say that the 787 Dreamliner is made out of a carbon sandwich.
A carbon fiber sandwich. Delicious.
Actually, it's just carbon sandwich.
Oh, darn it.
Carbon sandwich. Can I have another carbon and jelly sandwich?
Okay. Carbon is present in all known life forms and in the human body, and is the second most abundant element by mass after oxygen. And the difference between graphite and diamonds is a lot of heat and a lot of pressure, right? So if besides pencils and diamonds, is there another place where I might find carbon around the house? Maybe in the backyard?
Maybe in you.
Maybe in me. I'll just look for carbon in myself, and I'm going to switch to the next. element. This is
Actually,
this
you
is a good
could find it in your backyard. You could find it in the grass leaves, but it's in a microscopic amount.
And charcoal, if I had that kind of a.
Yeah, it's in the shed probably.
Yeah, it's in the shed.
It's in the shed that has posters of Homer Simpson inside.
Stop with the Homer Simpson. This is, look, we have a cool vase here. So this is a classy show now, all right?
Complimentary vase.
All right, what's the next element? You're going to have to read that. I'm not
you
touching that.
thought it was a spittoon.
No, it's not a spittoon.
Definitely not.
Can you read the next one?
Neodymium.
Neodymium? I am not a neodymium. You're a neodymium.
Hey! Hey, it's an element. It's an element. Switch back to that periodic table, please.
Do you think he actually switched?
No.
Oh, he's looking at the table now. So neodymium is on there, and if you can find it, oh, we just switched back. All right, so neodymium is on there. Carter, please tell me a little bit about neodymium, because I have no idea what this is.
Neodymium was
Yeah.
discovered in 1885 by the Austrian chemist.
Can I handle this?
Yes.
Karl Auer von Welsbach. Right?
Yeah.
Know what I'm saying? Uh-huh.
Pretty good Austrian.
Thank you. Can you read the next one?
Most of the world's neosmidium is mined in China.
China. Wait, but we're back to China? They've got all the
Neosmidium?
fusion. They've got all the neodymium. And what else have they got?
They've got
Be careful now.
They've got a lot of cities and they've got a lot of labs that say Spoxwood. I'm just saying.
All right, one more. This is my favorite part about neodymium.
It is used in a component
Uh-huh.
in the alloys used to make high strength neodymium.
Dymium.
Dymium. Meow. Magnets. Powerful. Permanent magnet.
Wait, what's the difference between a permanent magnet and a what's a not permanent magnet?
I don't know.
All right, an electromagnet is a non-permanent magnet.
What?
You turn on the power, magnet. You turn off the power, it's not a magnet anymore.
And then I turn on the power again.
So your fridge
the
magnet.
TV comes on.
So a fridge magnet, is that a permanent magnet?
No. Wait, no, it is.
If I turn off the fridge magnet, does it fall off the fridge?
No. It falls off the fridge. Hey, that hit my toe.
So neodymium is a magnet, whether it's
We
got
have
power
some
going to it.
humor. This is also a comedy, not just a science show.
And a musical, as you know.
It's the musical of Did You Know? You're learning science as you hear the musical. Yeah.
I have nothing to say to that. All right, so a neodymium magnet is a really powerful magnet, right?
A really powerful magnet.
You know what my friend Mark?
Hey.
I'm going to give a shout out to Mark. You know what my friend Mark Feldman said about neodymium magnets? They're called pinchers. You know why?
Ow!
They're super strong. Do not get your finger in between two of them.
I saw what it did to a tomato.
You did? When did you see that?
I saw it on Nova.
Oh, really?
It was like it got squashed. Oh. Huh?
Okay.
Huh? This?
So Carter wants. Okay, so you know I had this crazy idea that just popped into my head. What is gravity?
Why are you talking about this? This is the elements.
Don't.
Gravity is a permanent magnet, but it's a different kind of
Wait,
magnet.
no,
It isn't a kind that uses iron, but it's a kind that uses mass and density.
But gravity isn't magnetic power. Gravity is a different force altogether. There's electromagnetism, and then there's gravity, and they're totally different.
Well, I saw a sign saying gravity in a
I saw
question.
that sign too. But sometimes you see signs that are just wrong.
Wrong. Okay, we are experiencing some technical and wait. I think this was the tango dancing episode. You have to keep.
You are not allowed to get out of that chair to tango dance.
I'm not tango dancing.
Oh, wait, this is one of my favorite elements coming up. This is one of my favorite elements coming up. I know. So read the next one.
Uranium. Uranium.
Uranium.
Uranium.
No, uranium. Wait, why did you do that? What are you trying to tell me about uranium?
It was used in a bomb.
What kind of a bomb?
Nuclear kind? But
Really?
it was used in the first one. Plutonium was used in the next one.
So was the uranium bomb, was it fission or fusion?
I think it was fission.
You're right. It was fission. Tell me something about uranium. What is this mysterious, crazy stuff?
It used to be found in collectible Fiestaware.
Yes.
And
yes.
collectible Fiestaware.
Yes, they used to
oh, it's uranium. Ah, I feel hot.
What Carter is alluding to is that they used to make plates called well, we're not going to like say their name, but they used to make these plates about 80 years ago, and one of the ways they got the
80
cool,
years
groovy
ago.
colors was to use uranium glaze on it. But
Uranium
they were radioactive, so you get that along with your meal.
You get, and then you turn into a superhero. No, you don't.
All right, so keep going though. Keep going. Collectible Fiestaware. It was used to make a
Shiny red-orange glaze.
So if you
or
wanted to get that really
orange.
red, orange, or orange.
Orange.
So if you wanted a red-orange
Ow.
glaze on your plate, and you also wanted your food to glow in the dark, hey, you're all set. What's the next one?
It is also found in collectible Fiat.
No, the next one.
A component in atomic Fiesta.
No. Stay with me. Stay with me.
In atomic bombs and nuclear reactors.
That's right. They use uranium for that.
And maybe in Fiestaware.
Yes. Got to bring it down, though. Got to bring it down. It's a very
Bring
serious
it
show.
down.
Carter, remember we're on PBS.
Oh,
this
so,
time.
wait. We're not on PBS. I said I made a mistake.
All right.
I made a mistake.
So it's a component in nuclear bombs. And now what's the next fact? One of the...
Heaviest naturally occurring element. In fact, it is the heaviest naturally occurring element.
So by heavy, you mean each atom of it is chunkier than any other atom?
It's chunky.
It is chunky. Mhm.
Actually, it isn't as chunkier as any other atom.
What? So if the
There's other atoms that people have made by is it fission or fusion?
well, it's called a bombardment. They'll bombard.
Bombardment.
All right. Got to bring it down.
It's
Can't
a
get too
musical,
crazy.
remember?
Oh, not too musical though. So when I dig up uranium in my backyard, what does it look like? Is it uranium or is it mixed in with something?
Mixed in with something.
Do you remember what that's called? Do you know what that's called? What
What
that soil is, that dirt, rock, whatever they dig up? What's a word for that?
I don't know.
Pitch blend?
Pitch blend, or maybe, pitch blend.
Pitch blend, and it's kind of mixed into that, right?
Your pitch blend.
And remember, you told me the color of it, right?
Black, kind of dark browny color.
Yeah, it's kind of a browny yellow color.
Browny yellow. Yeah. When I saw it, it kind of looks kind of gooey. I felt like I was going to throw up when I saw it.
Yeah, that's not good.
Yeah.
Let's go on to the next one.
Silicon. Take the pencil off.
Why is this here for silicon? What does this have to do with silicon?
It is a tiny circuit board I found.
Mm-hmm.
Silicon is one of the most common is the 8th most common element in the universe by mass, but very rarely occurs as the pure free element in nature.
So, the non-pure version of it, the silicon oxide, would be like silica, and that would be like beach sand, right?
Silica.
Yes.
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 Yeah. How much silica does silicon have? Because silica is silica.
Yes. And
Say
that's
that
an
10
element.
times fast.
I refuse to. And we have one more to cover, and we're running short on time. So we have one more to cover. Titanium. Now, why are you bringing out something from our airplane show to talk about titanium?
This
this have to
one
do
was
with
made
titanium?
mostly out of titanium. I don't know if we said it on the second episode, but yes, it does. It has a lot. It has a lot of titanium, about 85%.
And this is the SR-71 Blackbird.
The SR-71, yes. I think you might, if you watched this show before, you might remember it from our second episode.
And why did
Planes
they
throughout
use?
the ages.
And why
to
did
be
they
correct.
use titanium on the SR-71 Blackbird? What properties does it have that make it really good for that?
Was it? Wait.
It's really
Something else made out of titanium. Strong.
and it's really
Smooth.
light.
Why?
It's light and strong, which makes it
This
perfect
is
for airplanes.
actually made out of titanium. If you see the glint, it's not plastic.
So yes, and the
actually
Soviets
pretty
also made
heavy.
a submarine called the Alpha, which NATO called the Alpha, which was
It's
made.
actually not It's actually not written alpha with a PH. It's actually it's just ALFA.
Which is kind of a goofy way of saying alpha.
Alpha.
Don't go there. So titanium is also alloyed. What does alloy mean when you alloy a metal?
Alloy.
What does it mean when you alloy metal?
When you alloy metal means to
Mix it, right?
mix.
Yeah, you're not
yes.
bonding it like a molecule, but you're just mixing it together.
Just mixing it. Just
So
mixing it in a giant kitchen mixer.
yes, a giant kitchen mixer that gets up to 3,000 degrees. So when you mix titanium with gold, it makes a really cool alloy,
Titanium
which is
with gold.
strong,
Yeah, strong.
but
And
still very
can
pure
be categorized as 24 karat gold.
because it has very little titanium to make it strong.
Yes.
So that is our episode on the elements.
Wait.
We've what? No, because
not-
we've got to the we're at the 2-minute point, so we're in wraps now.
Sorry. Let's wrap it up. Wait, we haven't discussed all the facts.
You know what? People can do some
sorry,
research on their
everyone.
own.
Yes, you can, but I don't want
I
to
know,
make them
I know.
unhappy, please.
No, Carter, they are
Please
so happy.
understand.
They will understand. They got to look at the periodic table, for goodness sakes. Should I do the snap again?
Yes.
And we're back to the periodic table.
Hi, everyone.
We want to thank you for coming in and letting us darken your doorstep again with Did You Know? We promise not to be gone quite so long next time. We have lots more shows coming in. I'm the only one that can do it. I'm the only one with the power. Yeah, you can snap. That's pretty good.
Yeah, but I can't really whistle.
All right, so Carter, would you take us out and say goodbye to everybody?
Well, everybody, goodbye, and please watch our other episodes if you haven't seen this one already. Goodbye.
Goodbye, everybody. Thank you.
Goodbye, everyone, and this is PBS. Sorry, buoy cable.